Have you ever really thought about what waiting in line for coffee has in common with, say, sending a document to your printer, or how a website handles a million clicks all at once? Well, it turns out that simple, everyday act of waiting your turn is actually one of the most powerful and fundamental ideas in all of technology. It's this invisible line that brings order to our entire digital world.
It kind of seems weird, right? I mean, why would we teach our super fast computers this very human, very patient concept of waiting in line? Why can't they just, do everything at once?
Well, because without a system for waiting your turn, you just get pure chaos. Seriously, just imagine your printer trying to print 5 documents at the exact same time. You'd get a jumbled mess of mixed-up pages. And that's where the line, or what the tech folks call a queue, comes in. It makes sure the tasks are handled one by one, in a predictable and orderly way.
And this whole system of fairness is built on one simple, powerful rule that you already know from everyday life. First in, first out.
It's a really elegant idea, and it works exactly like it sounds. If you're the first person in line for a concert, you're the first person to get a ticket. Simple as that. Technology uses this very same logic to manage all of its tasks. And of course, in the world of computer science, we have a fancy name for this. FIFO. It stands for first in, first out. It's pretty much just the technical term for the simple act of forming a line and being served in the order you showed up.
Okay, so let's just trace the journey here. A new task, we'll call it item 1, enters at the back of the line. Then, when item 2 arrives, it lines up right behind it. Now, the system only ever serves from the front, so item 1 gets processed first, and only after it's gone does item 2 get its turn. This guarantees fairness. No cutting, no skipping, it's perfect.
But for a computer to actually manage this process, it needs a specific set of commands, a kind of language for the line. So, what are the basic moves?
Every queue has 2 critical points, a front and a back. And the rule is simple and it is unbreakable. New items can only join at the back, and items can only leave from the front. This strict separation is the absolute secret to maintaining perfect order.
These actions have their own special language and programming. So when we add an item to the back of the line, that's called enqueue. When we serve the next item from the front, we dequeue it. Sometimes, though, we just need to see who's next without actually serving them. That's called a peek. And of course, before we do anything, we might want to check if the line is empty. With just these 4 simple commands, a computer can manage pretty much any line imaginable.
Okay, so we've got a simple rule. First in, first out. And a few basic commands. This might all seem a little abstract, but this is the moment where it connects to, well, everything. This system is secretly running the digital world all around you, every single day.
So why does this matter to you? Well, the reason your apps and websites don't feel chaotic is because of these invisible cues. They bring a sense of fairness and predictability. When you send a message or click a button, your request gets in line and you trust that it's not going to be skipped over for a newer one.
Seriously, once you start looking, you'll find them everywhere. Calling customer service? You're in a queue. Printing 3 documents? They line up in a print queue. Even just loading a web page involves your request waiting its turn on a server. Your computer's processor is constantly just working through a queue of tasks. It's like the invisible traffic cop of the digital world, making sure everything flows smoothly.
But is first come, first served always the best way to do things? I mean, what happens when you need more efficiency, or when a super urgent task needs to skip the line? For that, we need to make our queues a little bit smarter. Let's look at 2 clever upgrades. So on the left, we've got a circular queue. Instead of creating wasted space at the front as items leave, it cleverly loops back around on itself. Think of a music playlist on repeat. It's incredibly efficient. Then on the right, we have something called a dequeue, which is short for double-ended queue. This is like a line with an entrance and an exit at both ends. This is perfect for something like an undo function in a text editor, where you might want to add or remove the most recent action.
So the big takeaway here is that this really simple idea of a line is actually incredibly flexible. By just changing the rules a little bit, we can adapt it to solve all sorts of complex problems, from saving resources to handling emergencies.
But no matter how complex the system gets, it all comes back to this one powerful idea. So the next time you find yourself waiting in any line, just remember this principle. It's the very same logic that's quietly making your entire digital world run smoothly and fairly.
So, we've seen how order and fairness are hardwired into our systems. But that leaves us with a pretty fascinating question. what happens when some tasks are just more important than others? What happens when a system needs to let someone cut the line?